First, we'll go through the question and we'll understand what it's trying to say. And then we'll go through an example and then code along the solution. And we're also doing that, we'll also discuss the constraints. We'll be using Python 3 for a solution. And let's get to it. Okay. So here it says that given an integer array nums, return the third distinct maximum number in this array. If the third maximum does not exist, return the maximum number. Okay. So for example, we have an array nums with 3, 2, and 1. The first distinct maximum is 3, the second distinct maximum is 2, and the third distinct maximum is 1. And the output is 1. So it doesn't change the order. Okay, then the second example says there's this different array nums when the elements are 1, 2, and the output is returned as the 2, as the first one is also distinct. The first distinct maximum is 1. Oh, I see. Okay, I apologize. What is basically, it's going in the descending order. It's coming in the descending order. The first distinct maximum is 2, the second distinct maximum is 1, and the third distinct maximum does not exist, so the maximum 2 is returned instead. Okay, so the third example says there's an array nums 2, 2, 3, 1. So the first distinct maximum is 3, the second distinct maximum is 2. Both 2's are counted together since they have the same value. The third distinct maximum is 1. So 1 is returned. Okay. And the constraints says the constraints tell us that the length of the array can be anywhere from 1 to 10 raised to the power of 4, 10 exponent 4, and the value of the number, the integer, is anywhere in the integer value range, 32-bit integer value range, maximum and the lowest. Okay, so I think we understand. Let's reiterate it. We'll be giving an array. For example, this nums, example 3, 2, 2, 3, 1, and we have to find, and we have to go in the descending order from the highest maximum to the lowest maximum, and we'll have to return the third maximum value that is stored in the array. If the third maximum value does not exist, we will have to return the preceding maximum value. Okay, so let's get into the coding. Wait, possible solution could be we can use a set. Okay, possible solution. We can use a set which will give us the unique values in list, and then we can iterate over the length of the set to return the third maximum value in the set, or I think so, and let me just confirm, set sort within sort. I think there's a built-in method that uses this sorted. Sorted method is also there. and wait a second. Python sets every 3 scrolls. I'm pretty sure that's gonna have something here. Set items ordered and unchangeable. Set items are unordered. Okay. My set and set. Okay, let's see. Yeah, this is a separate ID that we can use to check for different methods of a set. We can initialize a set array. Let's say it has 1, 2, 3, and okay, now the set A has 3 integers, 1, 2, and 3. Let's see what are the methods here. Add, clear, copy, difference, and update, pop, remove, union. So there is one thing, so we can sort it like this. Oh, sorry, that will be sorted. Yes, we can have it like this. Or let's just go back to the lead code. We can sort the set and return the third maximum value or the value preceding it, in case there isn't a third maximum. So let's get to it. Step number 1, that's it. So we'll have nums set as a set, and we'll put nums here, and we can put it alongside so that we can see we're doing the right thing. Just for sampling, we'll run this and we'll see the output. Oh, sorry, there was a typing error. That's strange. Let's just so sorry, I'm very sorry. This, okay, so we can have this, see the set. It's returning 1, 2, and 3, and then we can put it back. S for S, sorry, S for S in nums set, and then print this distinct list in 1. print this as well. Distinct list. And 1, 2, 3. And then it's 1, 2, 3 again. And we can also distinct list is equals to list s for s in the set of index, and then we will print distinct list just to make sure that it's working. And hopefully it is, and it is. Okay. So now the only part left is we'll sort the distinct list dot sort using the dot sort method. This happens in place. It doesn't return anything, but it takes the list and it sorts the array, sorts the list from ascending to descending order, which means that the first value will be the smallest, the second value, and print it again. The second value will be the second largest, which in cases is just as it is. Let me demonstrate this with a test example where we have actually a couple of more. Okay, so when we run this case number 4, what we can see is the third maximum here would be 3. So which means to get the third maximum, we'll have to start from the end of the array. In Python, this is fairly easy. What we can do is take this distinct list and set the index to -3, which will give us the third maximum. List index is out of range. Okay. Okay, so we'll just for the debugging purpose, we'll take this distinct list -3, and let's see what this returns. Return 0. Third max is 1. Okay. Oh, this is for the case 4. Yes, so what we can see is that if the list exceeds, if the list is only consisting of 2, less than 2, or less than 3, then it's going to return us an error. So we can try this and return the distinct list third maximum, or we can put an except block here, which means that it doesn't exist. And we can try it again and return the distinct list -2, and if that also raises an error, then we can simply return last one, or which in case is only 1. So we'll comment this, and we'll comment this, and we'll check our results. can lock it here just so we can have a clear view of it. There's another way to do this. We can just use simply the if length of distinct list is greater than 3, then we can return distinct list at largest elif length of distinct list is less than or equal to 3, greater than 2, then we can return distinct list -2 else simply return distinct list 1. Try running this again. Let's check our results. Runtime error. If the length, oh, I'm very sorry. Sorry about that. This is again gonna be an error. Okay, let's run this. Seems like we're having a bit of an issue with returning the correct value. Okay, so where is the error actually? In case 1, the output is returned as 2. Okay, so this means that it's giving us this guy. Okay, just for the sake of testing, let's say I have a list B and I have the elements 1, 2, 3, 4, 1, 2, 3. Okay. Now when I print B -3, what will this give me? It will give me 1, which is correct. So for the length of 3, this works fine. And when I check the length of B, this is 3. Okay, so let's update our conditions a bit, which is greater than and equals to 3 and less than 3 and equal to 2. And let's run this again. Okay, this is still giving us an error for case number 2. So okay. That's correct. That's the correct answer for all of the cases except for case 2. Which is returning the output 1, which means that it's returning here. Whereas the length, let me just check this condition here. Because I'm pretty sure length of v, to make this 1 2, the length of v is 2, and this condition gives true. The output is 1. Seems to work fine. And we need this code blocks. Okay. And so the output is 1, and this is expected maximum is 2. Second distinct. Okay, let's go through the example 2 again. First distinct maximum is 2, second distinct maximum is 1, third distinct maximum is 0, so the maximum 2 is returned instead. Okay, I think, this is my fault, I am very sorry. It says here, if the third maximum does not exist, then just simply return the maximum number. Okay, so if that doesn't exist, then we'll just simply have to return the maximum number from this distinct list. Okay, so let's try this again. And it passes all of the test cases, which is very good. I'll commit this print statements and let's try running this once more, and then we'll try to submit it. Okay, so far the 4 test cases are all right. Let's submit and see the results. Thankfully this works, and we have the runtime is okay. It says we beat 83.31%, but we didn't do very well on the memory. Num sorted list. Well, that's a very neat solution. We did the same thing, except we used more variables and more number of lines. Okay, so the time complexity, we can also discuss the time. We still have little time left. So let's discuss the time complexity of this problem, the solution that we did. It says, okay, so the first thing it's doing, it's iterating. The first thing that it's doing, time complexity analysis. The first thing that's happening here is we are converting the list to a set. And the second we're doing is we are converting the set back to a list, and then we are sorting the list in place. And the fourth is we are checking the length of the list with an if-else condition. Okay, so these are the four main steps we are doing. So the first thing is we converted the list to a set. Okay, and assuming the time complexity of this is going to be O n, as it will iterate over all of the elements in the list and then place it in the set. And then we are iterating over the whole set again, converting that into a list. That will also be on. I just zoom the screen so that it's, yeah. And then we are sorting the list in place, which is again O of n, but n could be less, but n could be less than 1 in case we have a repetition of numbers. But taking the worst case scenario, it's going to be on. And then checking the length of the list will, well, Python uses a function to calculate the length. So in Python, this is probably going to be O of n again. In JavaScript, this might be O of 1, as it basically is, it might just store the value. So looks like time is up. Thank you for your time. Have a great day. Thank you, and Allah Hafiz.